Okay, welcome, Tammy and Richard and Joy and Taylor and Aze and Katie and Ashley. And like I said, Richard already, it always does weird ordering. The plan today is a bit shorter than we were used to. So hopefully you're okay with that, which means that you're going to be able to have lots of time to ask questions if you want. And please ask questions. What I'm going to do is I'm going to be talking about a few things. One is we're going to look at things that are coming up. Project. We got the online exam and chapter 6. So we're going to spend a bunch of time in chapter 6, which isn't that hard a chapter. And again, I lighten up a little bit this week because this is the week that you should work on all the other stuff. So let me remind you, the other stuff is going to be online exam and project 1. So first thing is the online exam. The online exam is quite long. So it's due on Sunday night. You get as long as you want to try, but at Sunday night, the deadline's over. So if you don't hit submit by Sunday on 11:59 or something, then it'll zap you. I don't recommend waiting until Sunday late night to do it because that's when computers die and it's really painful if you don't submit it. Okay, so the online exam is, again, it's much longer than the regular assignments. The other thing is that you only get one try, one attempt per question. So if you get it wrong, you got it wrong. So think a lot before you hit that submit button on each problem, because you don't get a second chance. So that's just a big note. So I look at it as an exam and not a quiz. Quizzes are just for practice. You get to try and try and try. Exams, you turn it in, you're done. That's kind of how exam works. So what I recommend is doing chapter 6, finishing that up, hopefully not too late this week because it's an easy chapter, and then start working on your exam. Don't wait until Sunday night, please. Okay, so is the exam time unlimited? No, it is not, because if you take longer than however minutes there are now between now and Sunday at 11:59, so that's what, 24 hours times 60 minutes times about 6 days, whatever that is. That's how long you have. That's the time on the exam, is until closes on Sunday night. How many questions are there? There's a bunch. Let me quickly grab it, and then I'll be able to tell you. Just a minute. Let's go check it out. And then I'll be able to tell you for sure, because I don't remember the exact number, but I will know in a minute. There are 50 questions on the online exam. Okay, there are 50 questions. So again, that's why we have a light week, because the online exam takes some time. Okay, let's see. Do you still have to take it? I don't think you have to take it in one sitting. When you hit submit for the whole exam, then it's over. So don't submit. Okay, submit one problem at a time. Does that make sense? And then you should be able to go back and do more problems. But again, once you've submitted a particular problem, you can't go back to it. So other questions? Okay. So again, it's the best way if you want to practice for the online exam is do the chapters 1 through 6 homework questions, because they're taken from those, to give you an idea. So they're taken from the homework questions. Any other questions about the online exam? Okay, and you will need your calculator, by the way. Yes, yes. So this is an online exam, which means it's computer graded. So you have to round property. What I do for a lot of these, though, is that I'll tell you to round whatever, and then I have a little extra on the computer for a lot of the problems. Not all of them, but a lot of them, the ones I could fix. So if you miss a little rounding, you're right. If you miss it badly, it's not good. Any other questions about it? Any other questions? Okay, so again, that is due on Sunday. So you need to get that done. There's 50 questions. They're long. Don't wait until Sunday to do them. Okay, that's a huge suggestion. Chapter 6 is covered, so I recommend doing Chapter 6 first. Okay, but again, Chapter 6 is one of the easiest chapters in the book. I think Chapter 13 might be a little easier for most people. No one complains about Chapter 6. Okay. The other thing I really want to mention is February 10th. What's due on February 10th? Which is a week from Sunday. Yeah, the project. Okay, so you really want to be getting going on the project. Okay, remember that if you don't send it to me, your rough draft, if you don't send me the rough draft by Thursday, that would be, let me go check February 7th at 8 a.m. That's your last possibility to send me a rough draft to get full review. So that's a week from Thursday morning. So you don't have that much time on that. So again, you want to work on that this week also. The other thing is if you haven't already grabbed a partner and gotten your idea down, you should be pretty concerned. You should have sent your idea, posted it on the project forum so I can let you know whether it'll work or not. Okay, I want to help you, but I can't help you unless you do things like post your project question. And then I could look at it and help you. Okay, there's a lot of them that needed, most of them actually needed some little tweaking. So if you don't go ask for help, then you're going to miss the tweaking and it's going to be bad for you. So that's really important. Strongly recommend that you post on the project discussion forum your idea. The other thing I noticed on the project discussion forum, let me go to it, just so I can tell you the name because I don't remember exactly the person's name. It is coming. Takes a second. So on the project discussion forum, there was one of your classmates, Timothy Helweg, is looking for a partner. Okay, be nice. If you only have 2 of you, it'll be easier to bring Timothy in. Got it? So if there's only 2 of you in your partnership, do that. And that way you're helping another person and you're helping yourself because you can make Timothy do some of the work that you would have had to otherwise do. Does that make sense? So make sure that all those that are posting up on the project discussion forum find a partner if they're looking for someone. Any questions on that? Okay, let's see. We got one. So long as we do not press submit completely, we can go back to the other problems throughout the day as long as it is finished by Sunday. Yeah. And again, I recommend not letting Sunday be your goal. I recommend being Saturday be your goal. Okay, or even Friday if you can. That way, if something goes wrong, you got an extra day. Okay, it's just a good way of doing things for pretty much everything in life, is that if you can get it done a day early, then you're less stressed and you'll do better when things go wrong. Okay, and especially technology. Technology happens. And some of you know already, if you ask on Sunday night, can I have an extension? What do I always say? Or just about always? Yeah, no. Okay, so it's almost fruitless to even ask. Okay, there was one little thing that happened this Sunday. It wasn't about extension. There was some kind of weird tweak thing in the due date, and I fixed it. That wasn't an extension, but that was really due Sunday, not Saturday. I think someone thought it was due Saturday or something. Okay, so again, you need to get it done. If you ask Friday, I'll typically give an extension, but you shouldn't be getting an extension for the online exam. That's kind of important. Okay, the other thing I want to mention, the other thing that's due, I want to go over all the due stuff since this is a light day, is that you have the discussion post due, and that has to be done by Thursday. I recommend by Wednesday. to submit your initial post. And I also recommend, just like I did last week, but this week also, is to make sure on a piece of paper that you solve your own question, right? You're supposed to pose a problem just like you did last week. And if you can't solve your question, there's a good chance that it's not really a question that can be solved. Okay, and that's not a good thing. Okay, and look at the way I solved it. It should be very similar. So that's just a big note, is that if you can't solve your own, it's a bad sign. So either you made it too hard or it just doesn't even make sense. One of those two things. Okay, there are a couple of those. I'm still grading those. I'm grading a calculus test to grade today. I want to get those done, and then I'm going to finish grading yours. So while I was giving the test, I graded some of the last week's discussion. So that's the other thing that you have to do. And of course, the secret word quiz, but that's easy, especially since you're all here, because we'll have a secret word towards the end. Any questions before I get into content, which is pretty light today? Any questions? Okay, and you notice, hopefully you notice that when you post, I'm pretty good about getting back to you guys all. I don't know if you've noticed that, but it's not going to take that many hours to get back. So please post questions when you do have them, when it's not a webinar time, when you can just ask. Okay. All right, so let's go and let me share Paint, and I'm going to talk about the normal distribution. There it is. Okay. So the first thing is the normal distribution. It's very specific what it looks like. So let me draw it. It's one of those things I have to draw with the brush. Ooh, that's kind of thick. Okay, get rid of that. Let me do it one more time. Ooh. How's that? Oh, still pretty thick, but I guess we'll do. Okay, so the normal distribution looks as follows. And again, I'm not a perfect artist, but that's good enough. And something we call the standard normal distribution has mean of 0, and it has a standard deviation of 1. And this is called the standard normal distribution. Any questions on that curve? It has another name that's more a simplistic name, but in our class, we're going to call it the normal distribution. I want you to call it the normal distribution. The other name you've heard is bell curve. Y'all heard that before? Yeah. So it's shaped kind of like a bell, but we call it the normal distribution. Okay. What I'm not going to do is make you memorize the formula, which is 1 over the square root of 2 pi sigma times e to the negative x minus mu quantity squared over sigma squared. Okay, notice I said it really fast because you don't need it. But I do want you to know that it's a function. So there's a curve, and that's what it looks like. And you do need to be able to draw this. Force yourself to draw it on paper a lot, because you're going to have to do that for the midterm and the final. You're going to have to draw normal curves. Any questions so far? Okay, it turns out it's one of these weird things that you look at it and it's like, well, why do you care about it? Especially I spouted out that horrible long formula for it, which I told you not to remember, messy, why is this so important? And all I can tell you is hold your breath. Next week, we're going to find out. It turns out pretty much everything in the world follows the normal distribution if looked at right. Okay? And this you may not believe me, but you are the normal distribution. Every particle in your body follows the normal distribution. So if you don't understand, that's just fine. It's called quantum physics. So it's everywhere. But more importantly for us, that anytime you have a survey result and you're dealing with either a quantitative distribution, or if you're dealing a quantitative variable, or if you're dealing with a yes/no question, it doesn't matter. Either way, we're going to be using the normal distribution. Okay, so as long as you have asked enough people, and we're going to learn about that enough, but any guesses on how many people you have to ask to be able to say it looks like the normal distribution? It's a good try, Tammy, but you're not thinking about something special. There we go, Muhammad got it. Over 30. You've heard that number before, right? Again, that was supposed to be a subliminal message. Yeah, so over 30 was the reason why in your project you have to do that, so that we're going to be able to use normal distribution, which you're not going to be able to do for your project, but for project 2 you're going to have to, and you're going to understand it. 30 seems small, but we're going to learn it's good enough. In order to really know, you need to be a math major. So you're going to have to trust me. So for now, that's going to be next week. The important thing is you understand the shape of this curve. A couple more things that are important. I'm going to draw some more. If I go back and make this a -1, what's that area between -1 and 1? We've actually had that before. Not in the webinar, but in the long video I talked about it, I believe, and also in the book. 0.68. Remember, 68% of the data for a normal distribution has a z-score between -1 and 1. Do you remember that from chapter 2, I believe? It happened? Okay, so that's really important. And if we go -2 to 2, let's change the color a bit. And you look at that area, it's going to get a little messier. That is 95%, or 0.95. Do these numbers sound familiar? 68%, 95%? And what you call that? Is a third one that's about to come? What, orange? We haven't used that yet. So if you go -3 to 3, and you look at that, getting messier, sorry about that, but that's what we have to do. Then that area is, yeah, they come from the outliers, but we had a name for these numbers actually. That was 0.997. Yeah, Chanel remembers. That's called the empirical. Remember the empirical rule? If it's a normal distribution, those are the important numbers. Okay, so that's really important. Notice, by the way, that if you're within 3 standard deviations, that's almost everything, right? 99.7% is within 3 standard deviations. So beyond that, we call it an extreme outlier. Do you remember that? And if you're within 2 standard deviations, that was 95%, and that's most of it. So we called it an outlier if you're outside that. Does this ring a bell? Okay, any questions on the picture? Any questions on the picture? Okay, I'm about to erase the picture. It will get redrawn, though. But I wonder... Oh, I see what happens. Well, maybe pop it like that. Okay, so let me erase the picture. Last chance, because it's hard to get it back. Go once, twice. Gone. Okay, so now let's pop in some questions. I don't know if I'll do all of these, but I have some set up just in case. All right, so we're not going to use a calculator. We'll get to the calculator in a bit. But right now I want to do it just with the picture. Okay, I bet you can all answer question 1, hopefully, if you're paying attention. So suppose Z follows a standard normal distribution, which was I just had up. What's the probability Z is between -1 and 1? Yes, 0.68. Okay, again, memorize it. Okay, let me go to the next one. The next one we're going to need pictures. Next one we definitely need to draw pictures for. And we want to find the probability that Z is less than 3. So what I'm going to do is I'm going to sketch it. It's all about the picture, by the way. And the picture is mandatory, by the way. All right. Everyone understand that that's the picture of Z being less than 3? Okay, what helps a lot, if you have 3 on one side, we should put the -3 on the other side. It makes it easier to try to understand what's going on. Okay, now we know how to find the area between -3 and 3. Do y'all remember? What's the probability that we're between -3 and 3? 0.997. So what we're going to do is we're going to take 0.997 and then we got to add that area. Any questions on that? Okay, something very important about the normal distribution is it's symmetric. Okay, it is symmetric. Adding which area? So we're adding the area between -3 and 3 to the area to the left of -3, and that'll give us everything to the left of 3. Does that make sense, Elliot? Okay, so we got to find that area to the left of -3. And we're going to use the fact that it's symmetric. So if you look at the area to the left and right, that's going to be 1 minus 0.997. That's everything but what's inside, right? So I'm going to write let's try one more time. One minus 0.997. Okay, but the thing is, that'll be the area that is outside. Is that clear? I don't want that area that's outside. I want only the area to the left. Okay, so if I know the area to the right and left, and I want only the area to the left, what do I have to do? Yeah, divide by 2. So I'm going to divide by 2, and that will give us the area to the left. Any questions on that? Okay, and that, by the way, 1 minus 0.997 is 0.003 divided by 2 is 0.0015. Any questions on that? Yeah, so now we just add them up, Elliot, as you said, and we get 0.9985.
This is
our answer. Question? So the answer is 0.997 plus 0.0015. And that again is equal to 0.9985. Any questions at all on that? Any questions? Okay, I'm not going to do all these because, again, we don't have to do every single problem I have ready. I'm going to do some. Okay, I think I want to get to D because D is really important. Okay, find the value of Z such that there's a 2.5% probability of being greater than this value Z. So I'm going to erase all the stuff I just did. And I'm going to redraw a picture. Same picture. So today the picture is the normal curve. Okay. So we want the value Z, so there's a 2.5 probability of being greater than this value of Z. So do you think Z is going to be far to the left or far to the right? Yeah, it's to the right. If there's only 2.5% probability of someone being greater than you, you're pretty great. Does that make sense? So that's the first thing to note, is I'm just going to mark it. Somewhere around there. Let's call that Z, which we'll learn in a little bit what it is. And we know this area is 0.025. Any questions so far? Okay, now what I'm going to do is I'm going to go to the other side and draw the symmetric side. What's the area to the left? Into this pretty easy. Yeah, 0.025, it's symmetric. All right, so now the question is, what is the area in the middle? Area always has to be positive, of course. Yeah, area can't be negative. That doesn't make any sense, right? You can't use a negative amount of ink to be able to draw something. Okay, so what's the area in the middle if the outsides are 0.025 each? See if you can do the math. Yeah, close, Mom, and it's actually 0.95 though. So notice that if there is 2.5% to the left, 2.5% to the right, that means the outside is 5%, so the inside is 95%. So now we know our picture. From the picture, what is Z? Now 0.95 is the area, but what's the value of Z on that horizontal axis? And that I showed you a while back. Yeah, that's 2. Because there's 95% in between -2 and 2. So the value of z such that there's a 2.5% probability of being greater than this value is 2. Okay, I guess I should warn you, today's a geometry day. Have you noticed? There's a lot of geometry involved. Because remember, this is a math class, so we have to do some math. And it's basic geometry. It's not proofs. It's counting up areas. Any questions on this? All right, I think I'm going to do another problem. Now we're going to jump to calculator problems. So let me go through and drop this. So by the way, if you're not ready for me to delete this, let me know right away. Or you're going to lose it all and not be happy about it. So I've gone once, twice, done. All right, so now let me pop in another question. The next question is the exact opposite of the last one in terms of what we're going to try and do. And I'll do some of them. I don't know if I'll do all of them. Remember, last time it said, do not use your calculator. This time it says, use your calculator for this problem. And it says, suppose that x follows a normal distribution with mean 114, standard deviation 23. So the first thing I'm going to do is I'm going to draw that picture. So we have a normal distribution. The mean is 114. So the mean is always right in the center on a symmetric distribution. Is that clear or is that confusing? Because the mean and the median are the same if it's symmetric. All right. And the standard deviation is 23. We'll use that in a little bit. We want to find the probability that x is between 100 and 120. And by the way, get used to this on the exams. You need to draw pictures. So we want to go from 100 to 120. And what we're going to do is we're going to shade. Any questions so far? I need to write some stuff down so I don't forget. So note another way of writing this, by the way, this top part, and this is something you need to learn how to write, and no one ever pays attention to me. And then do you know what happens if you don't pay attention to me on the final? Oops, that was a mistake. Yeah, you're going to miss it on the test. Okay, I will guarantee that you're going to have to do what I'm about to do on the test. Not with these numbers, but the same idea. I'm going to ask you to write down the distribution. And what you write in this case is x. Do it in red. Green doesn't look so good. So I'm going to go x. And then they're going to put a tilde. And then n. Any guess on what n stands for? Yeah, stands for normal. And then what we're going to do is we're going to write the mean first, 114, comma, and then the standard deviation next, that's 23. And that's called the distribution. So I'm going to be asking you on the midterm and the final to write down the distribution. And this is what I'm asking for. If you leave it, if you don't do it, I'm going to ask you other things on the same problem. If you don't do this, you're going to miss points because you didn't do what I asked. Got it? All right, next chapter, we're going to have more complicated stuff, and this gets more complicated. So you want to learn the easy stuff first so that you can get to the more complicated stuff next week and not have to start from the beginning. So this is what's called writing down the distribution. Okay, so now I'm going to be ready. So let me write down on paper, because I'm about to lose this. X tilde n 114, comma 23. And we want the probability that x is between 100 and 120. So I'm going to show you how to do it on a calculator. I recommend getting your calculators out because doing this by hand is brutal. Trust me, you do not want to do it. Even if you're an expert in calculus, you still don't want to do it. So I'm going to do a new share and go to my calculator. All right, so here's the buttons I hit. I hit second, distribution. We've seen that before. When did we see that? When did we see it? Yeah, last week when we did the binomial distribution, right? Okay, it turns out that we're going to do the normal distribution today. So the good news is normal is easier to get to. It's right there. This is something I don't like about this calculator. This first one that says normal PDF, if you ever use it, you've made a mistake. Got it? At least in this class. So they should not have made that number one. They should have made normal CDF number one. So we're never going to use normal PDF, but we are going to use normal CDF. So go to normal CDF, hit enter. I want to warn you there's two kinds of calculators. This kind asks for the lower, the upper, mu and sigma. The lower here is 100. The upper was 120. Mu is a mean, which was 114. And sigma is a standard deviation, which is 23. Any questions on that? Yeah, so we never use normal PDF in our class. Only mathematicians do. Yeah, sometimes the computer doesn't type in. I typed it, it just didn't. Oops, let's try again. 1, 0, 0. Got to hit the keys harder, it doesn't always do it. Your calculator probably won't have that problem. Any questions? If you have, oh, sorry. Yep. 120. If you have the older style of calculator, it's not going to show this. It's going to show what I'm going to show you in a second. It's going to show normal CDF with the parenthesis. Then you type in 100. You type in the comma. You type in the 120, the comma, the 114, the comma, the 23, and the close parenthesis. Any questions on that? Then I hit enter. Got a 33% chance. Any questions at all on using your calculator to be able to crank out these probabilities? Any questions? Okay, let's do the next one. Now I'm going to go back to the question. There we go. So I am going to get rid of the picture, draw the similar picture, but not the same one. All right, I'm going to go to greater than 200 now. So I have to get rid of what was there. Actually, not all of it. The distribution is the same distribution, so I'm good with that. So now I can go in and draw a normal distribution. And we have 114. And we want to be greater than 200. Going to be somewhere around there. Okay, so I have a question for you. If you look at what I just drew, first question's easy. What is the lower bound of what I just drew? That's an easy question. That's a hint. Yeah, that's 200. Do you agree that was easy? Okay, harder is what is the upper bound? Because the calculator needs an upper bound. Okay. And the answer is, the true answer is infinity. Yeah. The problem is the calculator can't do infinity. Got it? So instead, what I like to do is I take the number of significant digits. You see there's 3 significant digits in the biggest number we're looking at, 200, for example. And then add a couple nines to it. So I'm just going to do 99999. And that will work. So now I could go to my calculator, and we can do that. Let me write it down. Probability that x is greater than 200. So let me do a new share, go to my calculator. And if I go second distribution, normal CDF again. Okay, the lower now was 200. The upper, just a bunch of nines. A couple nines more than the significant digits, and you'll be fine. Mu and sigma were the same, so I don't have to change it. And I just go paste and enter again. Okay. So is the probability 9.24? How do we know before we even looked at the question the probability is not 9.24? Before you even started today, you knew that I couldn't give you one with a probability of 9.24. How do you know that? It's not a trick question, but it's an important thing to note. Any thoughts? Probabilities can never be bigger than 1. Remember that? So of course the probability is not 9.24 because that's ridiculous. You can't have a 924% chance of something happening. Is that clear? So you have to understand how to read the calculator. And this happens a lot, so know how to read it. And the key is you got to move your eyeballs over to the far right of your calculator, and you'll see that E-5. Any guess on what that means? Yeah, that's scientific notation. So what that means is move the decimal over 5 places. And when you do that, the first moves the decimal just next to the 9 on the left, and all the rest of them give you zeros. So our answer is 0.0000924. So let me unshare, and I'm going to write that out. So the answer to this one was 0 point, and then 1, 2, 3, 4 zeros, and a 924, which is very close to 0. Very close to 0 probability. Any questions on that? Again, it's really important to know how to use your calculator and to know how to read your calculator. Again, it's not hard if you know what to do, and if you don't, you have no chance. Okay. I'm just going to make a note on problem C. If we're looking at 90, I'm not going to do the full problem, but I want to kind of make a note on it. Let's go to brushes. There's 90. If we want to be less than 90, what's the lower bound? Not quite 0. Not 1 either. Yeah, negative infinity technically, but negative 99999 is what you'll tell the calculator. Is that clear? Okay, calculator can handle negative numbers. I do want to let you know that on your calculator, the negative button is not the same as a subtraction button. That gets everyone nailed, you know, all the time. So don't put subtract 99999, put negative 99999. And they're in different places in your calculator. The negative is below the 3. The subtraction is in between the times and the plus. Is that clear? So that's just some pointers on kind of common mistakes on the calculator. Okay, I want to go to E, because E is pretty new. E is going to be the one that we haven't done anything like before. So let me erase. I want to find the IQR. It's always the same picture to start with, at least. Do you remember what IQR means? What's IQR? Yeah, it's interquartile range. Okay, so what that means, since it's the interquartile range, what it means that there's going to be a value here and a value here such that the area to the left here is 0.25. Do you remember that's what the interquartile range means? And the area to the left of the upper bound, and we'll do that in green, is 0.75. Any questions on that? Okay, so now what I'm going to do is I need to find Q1 and Q3. So that's Q1, and this one's Q3. Any questions on that? So I do it with my calculator, but it's going to look a lot different. So let me show you. So here's the calculator. I'm going to go to second distribution like before, but I'm not going to go to normal CDF, because here, with normal CDF, I'm given values of X, and I find the probability, right? What I'm given now is the probability or the area, and I want to find the value of X. Is that clear? Yeah, and when you want to go backwards in math, we call that the inverse function. Do you remember that? So that's why we're going to go to inv norm. M stands for inverse, inverse normal, because we're doing everything backwards. Okay. Your calculator will look different probably. The area here is 0.25. Mu was 114. Sigma was 23. Tail is left. Yours probably won't say tail. Yours might just say inv norm, and then you type in 0.25. I think the point didn't show up though. So let's go 0 point really hard. There we go, 25. That's better. Yours might say inv norm, and you have to type the rest in, which is 0.25, comma, 114, comma, 23, because there's different styles of calculators. This is kind of one of the newer ones. Then I hit enter, and enter again. Okay, that's not the IQR, that's just Q1. So Q1 is about 98.5. Let me show you a little trick on the calculator. If I go second entry, it gives it again. I really want the 75th percentile for the second one. So I'm just going to move over, make that 2 a 7. Isn't that tricky? Okay, you don't have to do that. You could go back to inv norm again and type in 75. This is just a little faster. Hit enter, and you get 129.5. So now we could do 129.5. Except it didn't do it. Let's try again. 129.5 and subtract 98.5. Because that's how you get an interquartile range. You subtract Q3 minus Q1. And I get 31. Any questions at all? Any questions at all on this example? Is that clear? Okay, so let me go back. And I'm going to erase all of this. So again, let me know if you don't want it erased, but it's getting erased. And I'm going to put the next question in. Okay, now for a word problem. Again, so far all we've done is kind of mathy stuff. Now it's time for words. All right, here's the question. Suppose the time until you, or your wife if you're male, by the way, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Kind of the funny thing is last quarter I taught this was the day before one of the students became a father. Kind of cool. So I don't know if we got so lucky this time, maybe not. Okay, by the way, if the mean of when you're going to give birth is 140 days, what does that mean? Just in layman's terms, people always ask you stuff, and there's something you say. Average is not what you say, not about giving birth. Right? You ever heard, hey, when are you expecting, or when are you due? You heard that before? I'm due in 140 days. So that's what the mean of 140 days is. It means that that is your expected or your due date for having the baby. Does that make sense? And just to note, the 7-day standard deviation used to be true. It isn't anymore. I know that sounds weird, but now there's that thing called doctors. So if we're looking at pure natural births, 7 days is actually the standard deviation of birthing from the due date. Nowadays, there's something called C-sections. So everything changes. But 7 days is the standard deviation. Okay, so now what we can say, and I like to do this before I even read the rest. Yeah, I'll use that. Is we can say x with a tilde n we have the due date, or the mean, is 140. The standard deviation is now 7. Any questions on that? Now I can read the question. Your boss has just scheduled you, or your wife, for a business trip to China. Good idea or not? Well, you got 140 days. You should be fine, right? Okay. But you're going to leave today and you're going to return in 135 days before your due date. The big question is, find the probability your baby will be born in China. Okay? Yeah, bad idea, but we're going to find this probability. It's not a bad idea to find the probability, though, given that this is a statistics class. Okay, so what I need to do is, hopefully you're getting used to, is I am going to sketch a picture. This one's going to be a little smaller because I only have so much room. Like so. And we've got the mean is 140. And then 135 is out here somewhere. $135. Okay. Any questions so far? Okay, and by the way, today is what day? Day 0. Do you agree? So we have to go to the calculator. Trust me, you don't want to do this by hand. So we go to our calculator, and let me go grab it. 0 to 135, let me write it out. So x tilde and 140, comma 7, and we have in between 0 and 135. So let's go to our calculator. I'm going to go to distribution. Is this normal CDF or inv norm? Yeah, this is a CDF because we're given x values, we want to find a probability. So I'm going to go down 1, hit enter. Lower number is 0. Upper number was 135. The mean was 140. And the standard deviation was 7. So let me stop, make sure I didn't go too fast. Any questions about what I just did? Any questions? Okay, hit enter. And hit enter one more time. Okay, how would you feel about that, by the way? There's a 24% chance. What would you tell your boss? Okay. I hope you all would tell your boss no. By the way, whether you're a man or a woman. You want to be there for the birth of the baby. And if you're a woman, you do not want to be in China. Because if you're in China, by the way, the baby can't become president, for example. Because it has to be born in America. So you want your kid to grow up to be president, maybe. Maybe not. Okay, but you definitely don't want to be out of this country. Okay, so that's a bad idea. Any questions on finding this probability? Okay, may seem low, but it's not. Because remember that it's got to be less than 50% from the picture, right? So let me go back, and we're going to look at the picture and see why it's not that low. And that's one of the points of the picture is you get a good idea of what it is before you even go to the calculator. So notice 50% is to the left of 140. Do you see that? There's a lot of area here between 135 and 140. So it's going to be less than 50% by pretty much. Okay, a standard deviation is 7. So it's somewhere in between one standard deviation away and at the mean. So that's why not too surprising. And by the way, to the left of one standard deviation is 16%. You could do the math and you can figure that out. So I'm not too surprised of what we got. Okay, now let's look at part B. You decide that it's too risky. Do you agree? Okay, so you're going to negotiate with the boss. Okay, but again, you need to make money. You're going to have a baby, right? Quit your job, you lose your insurance, possibly, and not to mention your income. So, but you're going to negotiate so there's no more than a 1% chance that the baby was born in China. Does that sound more reasonable? Okay, so now what day should you ask to be the return date? Any questions on that? So I'm going to go and just draw it down here. Don't have to erase the other one because I have room. $140. And we want no more than a 1% chance. Okay, notice this is an area. 1%, by the way, what number is 1% as a decimal? Yeah, don't make the mistake and do 1 or 0.1, it's 0.01. I want to note another thing is that when you draw the picture, the 0.01 does not go on the x-axis. It's an area, so it's a demarcation of the area, 0.01. Is that clear? What we want is we want to find the value of x, because that's going to be what day number to be able to return. Any questions so far? Okay, so now that we've got that, let us go ahead and put in our calculator. So let's do new share. And I'm going to go to second distribution. What do I want now? Normal CDF or INV norm? I'd say or something different, but hopefully you know there's nothing different today. Yeah, this is INV norm is what it is, which is number 3. Because we're given an area, we want to find the value of x. That's inverse norm. I hit enter. The area was 0.01. Mu was 140. Sigma is 7. Left is what I want. And I hit paste. Any questions on that? Again, your calculator might look a little different because the TIs, they change style from here to there again. And hit enter. And that means I need to return by, I would say day 123. You always want to negotiate, right? So if you return by day 123, you should be just fine. Any questions on this example? Any questions? Okay, as I mentioned, you're not going to necessarily believe me right now, but the normal distribution is the most important distribution there is, even though it's just a weird looking thing. Okay? Turns out a lot of things follow a normal distribution. Not everything, but a lot of things do. And we'll see next week why. There's definitely a reason for it. Okay, so for now, it is time to write down the secret word. And the secret word for today is symmetric. Because if you remember, the normal distribution is a symmetric distribution. The left side and the right-hand side of the mean look exactly the same as each other. Mirror images. Any questions on this? Okay, let me pause my share so we can see each other. Oops. That one. Any questions about anything? I promise I got a little earlier than usual. 7:06, which is less than the 7:23, I think, or 28 or something that we did last time. But I'm happy to answer any questions you might have about anything. That could be the project, it could be the online exam, it could be about the normal distribution, or I don't know, what the weather's going to be like tomorrow, which I may not have the answer in your town. So how do you get the TI-84 on the computer? So that's a really good question. The answer is you really can't, but I will show you something. And I'll show you how to do it too. I think I'll do it from Canvas. Just 1 second. I'm going to share my desktop so you can see what I'm talking about. Just 1 second. Let me go to... There we go. And that one. Okay. So here's my desktop. So if you remember, I wrote that spreadsheet so it does everything. And a lot of times people don't even pay attention to the fact it does. So if you go ahead and there's a lot of ways of getting to it. I think course information might be the quickest from here. Spreadsheet resources. And you go to this one, and then this one. You'll need to go to File, Make a Copy. I don't because it's mine. And if you go ahead and go to Compute, then what I did is I created a way to get the normal distribution. By the way, it does binomial also. So for example, our mean was 140. Our standard deviation was 7. And I don't know, let's go 0 to, what did I say? I don't even remember the number. It was 135. And there it is. I tried to make it easy, by the way. So Joy, if you don't have the calculator now, you can still use the computer. There's a lot of other ways of, computer ways of doing the same thing, but this has everything that you need on our calculator. Everything we ever do, basically. And what I don't have, let's see. You wanted the calculator in time for the test. Okay, well, you can't use a computer on the test. You need to have a calculator. So either you need to borrow one from someone or you need to get one. eBay is the cheapest. That's what I found. Other than borrowing one, that's the cheapest because it's 0. It's free at our college, but you have to come to Tahoe for that. We have calculators to rent out for the whole quarter. And, oh, the exam, not the midterm. Oh, the fifth is fine. Okay, so you don't mean the exam, you mean the online exam. So you could use what I just did. Does that make sense, Joy? Okay, and by the way, it doesn't call it inverse normal. It just has left tail area. So if I want 0.01, for left tail area, There's 123.7 that we got in the calculator. Does that make sense, Joy? Okay, Ashley has a question. One of the quiz questions. The middle 60% of romance novels have between that and that many words. Average number of words in a romance novel is 64.395. Standard deviation is 17.110. Sim distribution is normal. Let X be the number of words in a randomly selected romance novel. Okay. So here's the deal. We got to draw the picture. So now let me go back to sharing my paint screen so I can draw stuff. That is, where is it? There it is. So let me get rid of all this. Okay, so the average number of words a romance novel has is 64.395. Yeah, this is definitely this week's, by the way, Chanel. Okay, so what I'm going to do is I'm going to draw the picture. Again, the picture is everything. If you understand the picture, it'll be easy. If you don't, then you don't have a chance. So we're told we have a normal distribution. The mean of that normal distribution, he told me, was can't see it. It's just back. How can I fix that? Can the rest of you see it? Okay, so this is going to be a tough one because everyone else sees it. So it's on your side. But I could talk it out. How's that? Okay. So the mean, just a minute, was 64.395. Just some messy number. Sorry about that. Let me type it. It's a little faster. $64395 is the mean. Okay. We want to the middle 60%. So the key again, as I mentioned, is sketching the picture. So the middle 60% is going to look something like here. And this is 0.6. Any questions so far? So the middle 60% means that in between the left and the right will be 0.6. Okay, now the key, because we're not going to do middle because the calculator can't do middle, but we can do left. So if 0.6 is inside, how much total is outside? This is why I started with the other type of problem at the very beginning, if you remember, 0.4. Now if 0.4 is outside, how much is to the left? 0.2. Any questions? Any questions on that so far? Might be tough because Ashley asked a question and she might have left. Hopefully she's coming back in. All right, so if we want to have this number, which we don't know, I'm going to call it x, then what calculator function do we have to use? We want to find x, and we've got all the pictures we need. Yeah, we also need, which I should have written it down because it's already way up on the chat, is the standard deviation was some messy number, 17,110. So let me write down x tilde n, the mean was 64395, and the standard deviation was 17,110. Any questions on how that works? Okay, so to get this, I use the inverse norm. So let me do inv norm. I have to text first, sorry. The inverse norm, again, our 0.2 is what we want. And then these ugly big numbers, 64395, comma, 17110. Okay, and similarly, because I think it asked for between what two numbers, so I need the other number too. So to get the other number, I'm going to do something very similar. But how is it different? Inv norm of so now what I'm going to put in? If I want the other number, the one on the right. Not quite 0.6. How much area is to the right? 0.8. Because 0.6 is that middle part, 0.2 is the left part, so 0.8 is everything to the left of the right boundary. 0.8 and then the same comma 64. Can't see it. 395. Comma 17110. Okay, and those are going to be the two numbers that it lies between. And again, you stick in the calculator or the computer. Any questions on that? Actually, it makes total sense now. So why 0.8? So let me write it out. So what we want is 0.6 plus 0.2 is equal to 0.8. And that's because what we want is all of this area to the left of our, let's call this, I don't know, y maybe. That make sense, Chanel? Okay, great, great. Other questions? Again, I always answer questions until you don't have any more, but I'm happy to answer them, going over examples or whatever. But hopefully you see the picture really is necessary. Otherwise, you're just guessing and it's too hard. But if you truly understand the picture, this stuff is not that hard. And on the exams, you have to draw the picture. I take off points. And you have to draw this x tilde n with the mean standard deviation. Any other questions? And as I mentioned, happy to answer questions, but if you want to go home or if you want to have dinner or whatever you're going to be doing, that's fine too. Project 1, if you're doing cluster sampling, we're not really concerned with differences in the individual means of each samples. Right, there are no differences. Yeah, in fact, it's really important. Let me reshare my desktop. Since I've got it up there, it's easy to show you. Oops, here we go. You can use the one var stats. There's just a bunch of numbers in A. There is no difference. If you have more than one column of numbers, you're doing it wrong. Got it? So But you are going to have multiple clusters, but they all go in the same column. So if you think you have more than one mean, you're wrong. Got it? You have one mean, one standard deviation, one histogram, one box plot, one stem and leaf, one Q1, one Q3, one IQR. Okay, good question though. Yes, you can, Joy, but there's some of the questions are from what I've just talked about today. So that's why I recommend doing the chapter 6 quiz first. I mean, you could have started last week, but that would have been a really bad idea. So you can start, but I recommend chapter 6 knowledge before you get to it. All right, have a good night, Elliot. Any other questions? I was at the other school and speaking with a psychology professor. He asked me where I was taking stats. He said, oh, well, that's nice. A psychology professor. I don't know all psychology professors. That's interesting. Maybe they know me. Oh, that's nice. You get to be part of his research. Hopefully it's not a pain study. Dr. Blink. That doesn't sound familiar. Attitudes towards cancer. Okay, well, that's kind of sad, but that's important. Especially if you have, if you have a survivor. Better to be a survivor than not a survivor. Okay, good night, Tammy and Taylor, and good night, Janelle. Good night, Richard. And Katie and Will, Muhammad and Azay. All right, good night. Okay. Okay, the best way to rule out convenience sampling is to do stratified sampling or cluster sampling for the project is what you're talking about. And then it's not pure convenience sampling. There's still gonna be bias, but it's just convenience sampling means you didn't even pay attention. Does that make sense? And for the project, you have a choice between cluster sampling, which should be representative clusters, or a stratified sampling, which should take the bias away of the strata that you're picking, at least for that part of it. And by the way, it's called convenience, not convenient. So it's IENCE is the name of the sampling. Any other questions? Okay, again, are you doing cluster sampling or are you doing stratified sampling? That's the big question. And then you have to explain how you're going to do it, once you decide. Because multiple days could still be convenience sampling. So if I walked around and asked people on Tuesday and then asked some more people on Wednesday, whoever I felt comfortable asking, then asked some more on Thursday, that's convenience sampling. Okay, so you need to have a scientific method, and that's the whole point of this project, or a big point, is to scientifically process the data and collect the data. Okay, any other questions, Will? Okay, great, great. Then have a good night. Okay, and for all of you who are watching this as an archived webinar, have a good night and or a day whenever you're watching it. Don't forget to find the secret word and post and do the secret word quiz, and then post on the Q&A forum or on the Project One discussion forum with any questions you might have. And I will call it a good night.